Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's evaluate the limit of the given function. Let us have this given expression, the limit of, let's say, 2x over x squared minus 3x as x approaches 0. Now, if you're going to apply here the limit theorems we've learned before, you would see that if you're going to substitute on our denominator, the limit of our denominator x squared minus 3x as x approaches 0 is 0 squared minus 3 times 0. 0 minus 0 will give us 0, right? Okay, while it is possible to accept 0 on our denominator, that would mean the limit here will not exist. However, here's the catch. When you are going to substitute the same c on your numerator, as x approaches 0, you have 2 times 0, that's 0, right? We will have an expression here, 0 over 0, which is actually an indeterminate form of a number. This is not equal to 1. This is no longer equal to 0. This is an indeterminate form in calculus. That would mean we are going to talk about another concept as to this. So if you have an expression like this where both numerators and denominators would be equal to 0, you need to do something else. Okay? Again, if it so happen, just if it so happen it's like that, then it's just okay. We simply declare that the limit doesn't exist because our denominator is 0. However, it's 0 over 0. So we cannot work on it. What we need to do here is this. Let me erase this portion. Look at our function. We can work on our function and see that there is something that we could do to make it simpler. I'm talking about, let me remove my function here. We have 2x over x squared minus 3x, right? There are actually terms that can be cancelled. Talking about factoring our x on our denominator. When you factor x, you will have x minus 3. Am I right? Because that's x squared. X times 3 is minus 3x. And with that, we have your x here and x here. In short, the simpler form of our expression or our function is 2 over x minus 3. Now with this, if this is what you're going to use, we could establish a certain limit. Okay? Even if the denominator would be 0, I don't know if it would be, but if it would become 0, this is still unacceptable in this at this point, because even if you will say doesn't exist, it's just as okay. But this is not even 0 nor doesn't exist, because if you're going to return here the limit of now 2 over x minus 3 as x approaches 0, as you can see here, you would be having the limit or direct substitution. You will have 2 over 0 minus 3, which will give us a result of 2 over negative 3. That's negative 2/3. See, the limit is actually negative 2/3. It's not an indeterminate form, nor it exists, as specifically because it doesn't exist, so it exists, right? So if there are cases, again, if you will have 0 over 0, you will do something else, and one of which is by looking at our function if we could actually factor something else. This is how we evaluate this given function. So what are you waiting for? Subscribe now!